morning to everyone. Good night to some other part of the world. Well, welcome all. I'm very glad to be here with all of you in this relevant project led by Mahidol University and Worldwide University Networks. It is a whole project where more than 10 universities cooperate around the world. And the topic of this training program is responsible and ethical artificial intelligence for future actions. So I really appreciate that you are here. If you, let me just remind you that there will be more than one session. This is the first one, but as long as you participate in more than 6 sessions of this training program, you will get an evidence of your training. So thank you very much for being here. And what I'm going to share with you today is try to understand generative AI to effectively analyze its potential benefits and risks. So I'm Claudia Camacho. I collaborate at the Institute for the Future of Education from Tecnologico de Monterrey in Mexico. My background is in STEM education, and I think over the last decade, I have been working, trying to innovate in education, but also to transform it towards a better future for all of us. And so let me tell you about my first encounter with generative AI. And it was in January 2023, and I was shared by one of my mentors this platform, and he told me, come on, ask him everything, or ask it everything. And what I asked about was some specific information about my PhD dissertation. And I was expecting, I don't know, maybe to say, I don't know that information because it's too specific to the field of soft matter physics. And for my greatest surprise, it actually answered me correctly. And it was one of the most passionate talks in my whole life, because for the one of the few times in my life that I could interact with an entity that knew as much as my project as I did. So it was great. It was really impactful. But then I thought, okay, is that possible? I mean, I was taught when I was a kid that there is a huge difference between human beings and the rest of the entities in the world. And that difference is the production of language, the creation of a sequence coherent of ideas, a coherent sequence of ideas that actually make sense and demonstrate that you have knowledge about something. And that was a proper characteristic of humankind that actually make a difference between humans and animals or plants or whatever other entity exists on planet Earth. So I was like, wow, there is something here that is different to everything else. And even I thought maybe this is some sort of um, black humor joke. It is some hidden camera joke. But no, with the days, I noticed that it was something real. ChatGPT was the first generative artificial intelligence that was open to the general public, that was open for two reasons. One, for us to use it, but the second one, for them to use and learn from the users. That is something that we usually do not acknowledge, but that is a common saying between the entrepreneurs with digital enterprises. And they say when there is no cost for an application is because the real gaining of those enterprise is yourself, your data, the data from the users. And ChatGPT, created by OpenAI, achieve a limit where they couldn't learn anymore from the data that they had only. So they actually were disclosing this application for we all to contribute it and allow it to learn from us. So, but let's keep going. ChatGPT, it's a dual sword technology. And it's even implied in its name, ChatGPT. OpenAI, the enterprise that actually created, said that it stands for General Pre-trained Transformer. However, it actually also has a different meaning and is general purpose technology. So general purpose technologies have appeared along the history of humankind. And they go from the invention of the wheel or the printing press up to the internet. And the characteristic of these general purpose technologies is that they are widely applied, which means they can affect they can affect the whole economy, the whole productivity sector. The second one is that they improve over time, becoming more efficient and effective as they are refined and developed and even used among the general population. And third characteristic of general purpose technology is that they have the potential to generate complementary innovations, because they often require substantial changes in business processes or methods for their potential to be maximized. And that is something, once again, quite relevant. Just as I mentioned before, for ChatGPT to keep improving, the need was for us as users to participate and interact with it. Okay, so after a while, just as I was shocked and impressed by the showing of this new technology, there were also some other burst of concerns about this dual sword characteristic of generative AI. There were multiple potentials to apply it and use it and improve human capabilities and make us more productive. But also there was another side of the sword, that concerning the risks. So right there are some impressive news that were published the last year. But one of the most impressive news was those where the journals like the New York Times or El País or other global reputable journals actually express and report the concerns of multiple stakeholders within society. For example, there was this Sam Altman, the OpenAI CEO, asking the Congress to regulate AI. And there was this other letter written by over 100 intellectuals asking for the same thing, because there were so many risks associated to the use of artificial intelligence. So in this address, that's why this project that we are here involved, it's so relevant, because we as universities lead the change in society. We actually propose changes towards transforming and evolving society and cultures. So in this sense, the project Responsible and Ethical AI for Future Actions that is actually funding by Gung University Networks is actually a great effort. And I give my congratulations to all the participants that are here, but also to all the researchers from the different universities around the world that are collaborating in this project towards the responsible and ethical use of artificial intelligence for future actions, with two purposes. One, improving the impact on the benefits that we can have, while at the same time minimizing the risks and ensuring that there are the fewest affectations or damage or injuries to human culture and society. And right here, I'm sharing one of the goddess of Mexicas, which were the basic or the native culture in Mexico. So Mexicas believed in this goddess, which was called Coatlicue. And Coatlicue was the goddess of fertility. Why? Because Mexica's culture, Nahuatl culture, was built on corn. And corn could only be created at the very beginning through just nature, right? Later on, we learned to actually control and manage agriculture. But initially, we couldn't do it. So the best thing we could ask is to pray to God to help us have the best production of corn. And maybe that is why do I introduce these ideas? One, to share my beautiful Mexican country, my beautiful Mexican culture. But also the second one is to remark, to highlight that we cannot manage and take out the best of the technologies if we do not know them. We cannot criticize, we cannot improve it, something that we do not know. So instead of creating gods or pretending, creating cape AI, which means giving AI some powerful powers that it actually does not have, we need to understand. And that's the motivation for this initial training. So let's learn, what is AI? The first thing that we need to understand is that AI is not something new. It has been within our environment. Maybe we have noticed like 2 decades ago, but it actually started almost a century ago. But the two last decades, from approximately 2004, there was a burst of applications with artificial intelligence. Let's start with chatbots, facial recognitions, Netflix recommendations, Facebook proposals, also Amazon recommendations, or Alexa answerings. So all of those applications actually concern the use of artificial intelligence. And they were called a specific or a short or limited artificial intelligence to one specific task. For example, Google Maps and Uber, or these other applications that guide us through cities, even where we do not know those streets, specific streets, and that actually optimize either the time or the trajectory or the energy involved in such track. They use artificial intelligence, but trained on one specific purpose, as I said, to optimize one specific task. So what is artificial intelligence? And that it's being a huge also discussion between technicians, scientists, and specialists on data science, computing, and many other disciplines. But as a practical definition, artificial intelligence, we can say that is the use of computers, mathematics, programming, and other areas to emulate, to mimic human mental processes. And as I said, this definition is subjected to multiple discussions currently ongoing. So let's take just this practical definition that we will use for this presentation. Okay, but what are the types of artificial intelligence? As I said before, there are different types of artificial intelligence, and they are being categorized into 4 different steps, which actually involve greater and larger capabilities each time. So the first one is weak AI, weak artificial intelligence. And that first step, what we want to describe is that applications that are designed to perform a specific task, such as recommending music on Spotify, or Siri responses, or Alexa responses, or user pathways. So those are artificial intelligence applications designed to perform a specific tasks. Then the next step is a strong AI. A strong AI has the ability to learn in a similar way to the way humans do. And that is right there when we said that it is so complicated to learn, right? Nowadays, we even struggle on how our brain learns. But as we will see, artificial intelligence has also tried to mimic the way we human learns and use our brain. Well, after that, there is a next step, which we have not achieved yet, but we are into the process of coming to this step. And general AI has the ability not only to learn, but also it has the ability to have intelligence and perform any intellectual tasks that human can do. So we could ask ourselves in which step we are. And there is a huge discussion also in this, but we are between a strong AI and general AI. And the final and most scary, but also with a great potential application is super intelligent artificial intelligence. And why is this one like the super top? Because it can perform all tasks that humans can do, but surpassing humans in every aspect. So this could include creativity, decision making, and the ability to learn, even each time in a better and more effective way. And that's where most of the concerns are, because we have imagined, we have in our minds these movies, fiction movies that actually shape our beliefs and that were related to this dominating species that was considering humans as threats. So before saying whether or not that is possible, I think, as I said before, we need to know how artificial intelligence works. And to decide whether or not, or the level of threatened towards human existence is will be decided by all of us as a society. That's why the purpose of this whole group of universities working together is to decide and to promote an ethical and responsible use of artificial intelligence. So let me share with you, there is, I'm sure most of you have gone through this process of regression or minimal squares procedure. That procedure is basic for experimentation. And I have shared it and published it in my book that it's called Experimentar y Medir, which means experimenting and measurement, how to learn in the real world. And what I proposed there, it was published almost a decade ago. And what I state there is that the real way to learn from our environment, from the real world, is to learn from data. And once we have data, we can analyze and create models about the system of a study or surroundings or universe or whatever we are studying. So the first way to do it is through linear regression. So in that case, we analyze only two variables, the input and the output. And we use math, that is just a linear equation, to calculate the output from the input, the y from the x, through one very simple operation, addition and multiplication. So if you think about it, that is the first step towards artificial learning. So you shouldn't, why do I explain this? Because this one, it's later being used into neural networks. Okay, but then, as I said, we have tried to mimic what the brain does. And in that sense, we first need to understand how the brain works. And there is this, this myth that says that we cannot mimic the brain because we do not even understand brain. And that is definitely true. We cannot understand brain, but we can try to mimic on what we know. It's even more amazing to say that actually neuroscience and neuroscientists have learned also from neural networks. And that is amazing. That is a way of how we humans learn through collaboration. But let's go back to the brain. So how the brain works. We initially have these wonderful five senses, the hearing, the sight, the smell, the mouth, the touch. So we gather data from our surroundings, from our system, and then we interpret it into some sort of ideas that is then transformed and analyzed inside the brain. We even learn from there to finally get an outcome or answering, or respuesta in Spanish. And that allow us to interact with our environment, to take better decisions. Okay, I put there consciousness. Consciousness will not be discussed here because that it's one of the powerful characteristics of brain that once again make us unique as beings in these planets. We have consciousness. But that will be coming in forthcoming sessions with my colleagues in other universities. But so let's go back. We need to mimic this and how we do it. Okay, well, we usually use traditional programming, but in order to learn, we first, as I said, we need to describe our world through data. Fortunately, that is nowadays possible. For example, when a plane is flying, it has over 400 parameters that describe its performance. Let's say the amount of fuel, the location, the functioning of the of every engine, or the propels or the conditions of the weather. So 400 parameters, 400 pieces of information are generated every second that an airplane is flying. So we have now the opportunity to describe the human life through data, thousands of data. They might be either structured or unstructured. And by that, we say structured, or we call unstructured data. Structured, I'm sorry, by those that can be expressed with numbers or maybe quantities, and that are quite structured, that are ordered. But also, there is this huge other side of unstructured data going from in ways of speech, in ways of writing text, written text, or videos, or posts, or like this whole lake of data that it's actually available to all of us through internet and data banks, databases worldwide. So we have that benefit. We have now the data. So what is supervised learning, or how do machines learn? So one of the first steps was supervised learning. In that case, we provide data to the computer, and we provide also the output. And what the computer need to do is to decide and create or identify the instructions that take us from the beginning to the end, from the input to the output. That is the case of a linear function, right? And I put an example there that is quite simple. Imagine I give the machine, the computer, these 4 images, and without saying what they are, just telling them, here they are. And the output is a camel, a penguin, a dolphin, a turtle. We give the input and the output. And for when we apply a supervised learning, the output are the characteristics or the differences between them, the ideas, the concepts, the abstractions that we have to identify, to actually characterize each animal. That is supervised learning. When we provide labeled data and its output. But there is also unsupervised learning. And in unsupervised learning, we provide only the input data. We provide only the pictures of these or images. And as the output, we have trends or patterns found in the data. That is called unsupervised learning. And in this, for example, in this case, in this specific example, the output will be a group of features, for example, saying viviparous or oviparous, or with 4 legs, or with the ability to fly, or with the ability to swim. That will be the outcome of supervised learning. And then it comes reinforcement learning. And in reinforcement learning, we provide a lot of data that is continuously changing, and we ask them to perform a task. For example, classify them. So the machine performs a task, and we say, yes, you're doing it fine. It's oviparous. No, it's viviparous. Or whatever we say, it's a way for providing feedback to the program and actually learn. And all these kinds of machine learning, as I said, depend on data. And what we must recognize is something, it's something that is being said among data scientists, and that is garbage in, garbage out. That is a common affirmation or saying among data scientists. And what it means, if we do not have correct data, then the output is useless. And in that way, we must think definitely what kind of data we are feeding to the artificial intelligence. If we provide bias data, limited data, what it's going to do is to give and provide outcomes based on that data. That's why there is also a concern about this data that we are feeding, or not we, but the enterprises that create and manage artificial AI or artificial intelligence to feed them their programs, to feed their systems. And that's why we need to pay attention to the kind of data. Okay, now, there are also these foundation models. So foundation models actually take all different kinds of general and large databases. As I said, they could be structured data, like expressed through quantities or quantitative or ordinal or categorized data. But also there are unstructured data, like text, images, speech, 3D signals, or videos. And so once we have our foundation model, we can pre-train it in order to make smaller task-specific databases as translation, content extractions, answering questions, text classification, sentiment analysis, text generation, or even other tasks. And this foundational model has been one of the greatest achievements of artificial intelligence, because there are different structures that, as I said before, try to mimic the brain. So one of the most important are neural networks, and two reasons why they are called neural networks. The first one is because they are actually trying to mimic the functioning of thousands of neurons that we have in our brains. And so it calls a networks because it also, as our cell brains are, or neurons, make synapses and networks to actually consolidate learning and make mind possible. There are also relationships between all these layers along the neural network. But let's focus. Right here in the figure I'm sharing with you, there are a lot of layers. And there is one, the green one, that it's actually the one that gets the first input. And in that, we need to be careful because there are specific there are specific arguments, there are specific algorithms that actually allow us to interpret those unstructured or structured data into a way that the neural network can handle it. And then it comes all the processes inside the mind. And those are represented through all the other hidden layers inside the neural network. Neural networks have evolved to something called deep neural networks. And what they refer is that they have larger and larger hidden layers, more and more hidden layers inside. And each hidden layer, it's made of multiple nodes, where each node actually has an equation similar to the linear equation that I show at the very beginning. But instead of talking about only one input and one output, one X and one Y, we have multiple inputs, multiple X, but also multiple Ys. And so that is represented through the different arrows that go from each node to the next one. And in each node, there is also something super amazing and interesting. That is the activation function. Not every node passes information to the next, to every node in the other layers or in the next layer. And not every node takes information from every node in the layer behind. Actually, there is something known as activation function. And that activation function decides mathematically whether or not to transfer information from the previous to the actual node and from the actual node to the next node. That activation function, it's also something relevant because depending on the activation function, it's going to be the outcome. What is super interesting and what it makes me feel like really passionate about it is the fact that this activation function has a simile in what happens in our neurons. So within the brain, we have thousands and thousands of neurons. And fortunately, not all of them are activated at the same time. Not all our neurons are working at the same time. Because actually, I'm sure you have heard that the brain consumes a lot of the energy that a human uses. And my grandma used to say that the mental activity is one of the most tiring activity. And when I was a girl, I couldn't believe it. And I was like, no, I don't think so. It's not the same if I add up and make additions and multiplications than if I keep running 1,000 meters. But actually, if you analyze it, it's unbelievable what we have in the brain, because not all of the brain activates at the same time. There are specific sections within the brain that actually activate and represent different tasks. So when we read, there is a region that is activated within our brain. When we talk, there is a different region that it's activated in our brain, and so on. And then that is actually highly energy efficient. Why? Because then uh, the our system must only focus on providing oxygen and sugar to certain parts of our brain and not to all the brain at the same time. And deciding that it's also represented as activation functions, something similar. And that has been recently proven, even at the level of the neurons. For example, there are a very tiny group of neurons related to number two, and another tiny number of neurons related to number three. So depending on what are we doing, not only certain regions of the brain activate, but also certain neurons, certain cells inside our brain activate. And that was an hypothesis first um, stated in neural networks and later on proved experimentally within the brain. And that is amazing because then, even though it is true that we do not know how the world, how the brain works, we are actually being able to contribute to the understanding of the brain, and we can work with neural networks. Okay, but let me go on. So just to summarize this brief relevant slide, we have input from the outside world or from the system in the form of huge data, huge amount of data that in the first layer must be identified, must be, no, not identified, I'm sorry, interpret in terms of how it's going to be analyzed inside the neural network, okay? And the next layer is just starting to work with it, and so on until we achieve the final outcome where there is also a decoder that transforms the outcome of the neural network to a way we humans can understand. Okay, and at this time, it's also, there are, let me go back here because there are also many other information that we need to recognize on how neural network works. There are two relevant and very important conditions, very important topics that I must talk about. The first one is the generation of new structures for neural networks. And one of the first one was this deep neural networks, but there are also convolutional networks and also other structures that allow not only the introduction of sequencing information, but the introduction of sequencing information that can be reused. And those are revolving neural networks. And what they do, let me, please give me a second because I might be, confusing the terms, and I do not want to tell you a wrong name. Um, yeah, it's the correct name is recurrent neural networks. And what they allow us is to take back the information that has been fed before. And that's why when you go into a chat um, generative artificial intelligence like ChatGPT, it is able to still remember the information that has been fed to it before. Yep, and that is quite relevant. And that is not the only advance of neural networks. There are also other structures concerning neural networks. And that those are called generative adversarial networks. And those generative adversarial networks are super amazing. But because what they have done is trying to optimize how we learn. So there is this neuroscientist which says that there are 4 pillars to learn. One is attention. The second one is the commitment to act, to actually get involved into the activity. That's why active learning is so relevant. The third one is an effective feedback. And the fourth one is like the to make the learning solid, to make it significant. Okay, so when we talk about attention, there is this first layer that it's actually fed into the neural network, and we interpret in terms of what the neural network is going to use. And right there, we have a coder. But there is also a relevant idea there that it's called transformer. And the transformer, what it does is to identify the relevant points, the relevant characteristics that we have to pay attention to, just like human brain learns by paying attention. And that at the end will be also the decoder. And then the third one was the feedback that we get. And that was why supervised learning was important and was a previous step. But nowadays, there is this there is this technology or architecture called generative adversarial networks. And what they do is to create 2 different neural networks. One, trying to mimic the real world, trying to mimic the original data. And the other one, trying to identify whether or not the data produced by the first neural network is actually real or produced by AI. So both of them interact with each other, incorporating the feedback into the process of the neural networks. And that is amazing, because then the participation of human analyzing thousands and thousands of outputs is diminished. What we can do is to see from these 2 neural networks and decide what are they going to optimize? And that optimization, it's called a loss function. And the loss function is something that we need to focus to tell us that we have achieved an optimus level of performance of our neural network. So that is the first one, that we are actually mimicking also the pillars of the learning. The other one that I want to focus is the computer demands required by this neural network. So I need to share this with you because it's really amazing what we are living. My father is a civil engineer. And I remember myself looking at him like really late at night, working with his regla de cálculo, a ruler that moves aligning lines and work by aligning lines to make calculations. And I saw my father doing it. And that has also been represented in mathematics, focusing on analytic solutions rather than numerical or graphical solutions, because our computational capabilities were really limited. But nowadays, we can perform calculations in a very fast way. Nowadays, I see my brother, which is also a civil engineer, feeding the data of a whole huge building, a skyscraper, for example, feeding some information, and within hours, having the calculation of the whole building. And I have been witnessing those changes along my life. So I am really, I share with this because I'm sure most of you have also been witnessing, are witness of such a huge evolution. Well, if we keep the same track, imagine the number of numbers, imagine the quantity, the huge quantity of numbers or parameters that are involved inside a neural network. OpenAI has reported that the number of parameters that they use for ChatGPT has become 2 trillions of parameters. So imagine being able to handle in our brains trillions of parameters. Obviously, that it's impossible for one single human. And it is also impossible for one simple computer, or even for a group limited of computers. So actually, what these have been, or what these demands involve, it's huge amounts of supercomputers that consume energy and consume huge amounts of water to keep them cold. And that also should raise awareness between the society, because every time we are using these neural networks, we demand a high amount of computational power and therefore a high amount of energy and water consumption. So there are also environmental issues related to the use of generative artificial neural networks, generative artificial intelligence, I'm sorry. So right here, I have some other slides, but this one is concerning what we might expect. I'm sure a lot of my colleagues will address these topics later on, but we are expecting that the existence and use of generative artificial intelligence will impact the workforce and the labor market. So that is something that we must be aware of. This is also an example of how ChatGPT 3.5 and ChatGPT are performing. The blue lines correspond to the performance of ChatGPT 3.5, the one that is currently open to the general public, in the performance of a standardized test. So we can see here, like, they got really high scores in AP tests, SAT, GRE, LSAT test, like many standardized tests around the globe. Obviously, or fortunately, it did really, really bad on topics like AP calculus. But the green lines correspond to the new version, ChatGPT 4, where we have which has also a vision capacity, or it has been incorporated with a capacity of analyzing images. That's why it's called visual capacity. And then its performance has improved. And that is one large advantage. Also, something important that I would like to discuss at this point. I have been in multiple discussions with other colleagues and in multiple conferences where people say, okay, artificial intelligence, it's not a threat. We shouldn't worry it, because artificial intelligence is incredible, stupid. And I could understand their point of view, since it currently goes into hallucinations, and it sometimes provides us incorrect information. In that sense, definitely, it is a very stupid entity. But on the other side, we must be aware that that is a relative point of view. And let's just think of relativity as Einstein proposed. It can, every single phenomenon can be seen depending on can be perceived differently depending on the observer. So right here, we have two options. We can decide, yep, actually, artificial intelligence is really stupid. Or we can go into the other side and recognizing that our brain has a huge, huge capacity. And that is, just as I said, two different points of view. Our brain, it's wonderful. It's amazing. It has huge capabilities. It is not only one of the largest brains between all the animals, but it's also highly efficient. And it can be, it has created the world we live today, but it hasn't been created through one single human. It has been created, the world, through the collaboration of multiple humans. So one other reason why it is not actually as stupid as it has been widely dispersed over the internet, for example, is the fact that the ChatGPT, for example, and other similar artificial intelligence have 80% of human knowledge into their background. 80% of all the knowledge of humans is available for these artificial machines. And in that way, obviously, it's a marvelous thing, because even a human, a single human, trying to memorize all that information couldn't be possible. And another important highlight here, the knowledge is actually increasing at an amazing, rapid pace. And it is said that every day there are more scientific papers published than those that a human being could read in their whole life. And that is quite challenging, right? For an expert to actually being called an expert, he could have to be reading and learning every single day without being able then to perform research. So actually, for the future that comes, we are going to have to deal, we're going to deal with artificial intelligence. So we need to be ready for those changes, not only for the simulation and the generative AI. We need to be ready for the climate changes. We need to be aware of our economy and care. And we need to build new infrastructures because our world is being reshaped. And it is true that by 2030, 80% of the jobs that will exist have not yet been invented. So we need to keep working. One of my papers that I have, that it's going to be soon published, that I will gladly share with you, it's related to a group of guidelines of ethical and responsible use that was created by a team of undergraduates. So what my team, my research team, and I did was providing training to those undergraduate students on the different capabilities of generative AI and how it works, what it need to be trained, what demands that they have for energy and for water resources. And at the end, they propose a set of guidelines that actually promote the ethical use of artificial intelligence. And in that sense, what we are doing as a collaboration, it's a great effort, because what I have learned from that research is that we cannot leave the big decisions concerning artificial intelligence to the governments, to the international entities, or even to the large institutions. We must all commit to the use of responsible and ethical use of AI as a community. We need to empower all the sectors of the society to actually take decisions in pro of the best of humanity, in favor of promoting it as a useful and maximizing its benefits and avoiding its risks. So I invite you to join and share this information with all your colleagues, with all your students, with all your friends and family. We need to start discussing about the implications of artificial intelligence in our world. If we join forces, I'm sure we can mitigate the risks and build together with robotics, with machines, through beneficial human-machine collaboration. But starting first as a society, as a community, joining forces towards regulating the use of these instruments. So thank you very much. These are some of the ideas that I wanted to share with you. I invite you to contact me if you have further information, or if you want to collaborate with me in my research. Right there, I'm sharing with you the my email, but also my webpage where you can find my lines of research. I will be glad to collaborate in even in this address concerning research on ethical use of AI, but also on other ways to use education to transform our society towards a better future. Thank you very much. I thank you for being here and listening to me. And I'm open to hear any doubts or comments for the few minutes that we have left. If you want, you can open your microphones, or you can write into the chat. If you have any doubts, please.
I'm sorry, can I ask you some question about artificial intelligence?
Yes, please go ahead.
Okay, so it have possibility that AI will have the emotional model in the next future.
Excuse me, can you please repeat your question?
Oh yes. So I have I want to know the AI in the future is have a possibility that have an emotional model in the future?
Oh, that is a quite a relevant question. I don't know if we are going to achieve to that point, but what I do know is that there is this group of people that it's actually trying once again to mimic their reactions. So I'm sure you have seen Sophia, this this robot that actually mimics facial expressions as humans. So it tried to mimic like surprise with big wide open eyes, or concern, or like, oh, I'm thinking. But that is something that it's something that not me, but we humans and a group of researchers are working on, but making them like really available of feeling and having sentiments of human do, that I couldn't tell you. I couldn't dare to make an affirmation about it.
Thank you so much.
Thank you for your question. Okay, I have another question online from Syria Gir. It says, how extensive for the AI ethics all around the world, comparing to the AI usage, since the trends go on, but for the governance still has much concerns? That is a super relevant question. Yeah, definitely the usage trends are like also increasing. There is this information that says that compares different applications available in internet. And one of the most widely used was Instagram. And Instagram achieved like the top number of users in, I think, 18 months. But ChatGPT achieved the same number of users in only 3 months. Worldwide users. And that tells us how fast is evolving. And that tells us also how fast is the technology evolving. Because as I said, every time we interact with the tool, we are helping it improve. So the evolution of technology, it's increasingly fast. However, governments are far behind being able to regulate it. So that's why my proposal is to disseminate the usage, but also fostering critical thinking and ethical empowerment, ethical usage, responsible usage, to be aware of what we are actually facing. And we must join maybe in school, in tiny groups, and learn about it and share our benefits. In these guidelines that will be, I will be gladly to share if you contact me, because it will be published in 2 or 3 months. The students pose one specific guideline of use, and that was something like, let me rephrase it because I don't remember really well, but it was something like, learn to use it and share everything that you learn in your social networks, with your family, with your friends. Tell them what it can be done right, but what it can do wrong. And in that way, as a community, we can act faster than governments or institutions can act. Let's take, for example, universities, which is what I know the most. Universities in Mexico take between 4 and 6 years to create new educational models. Obviously, there is a huge difference between 4 years for creating a new educational model and the fast pace at which new forms or new models of generative artificial intelligence is being created. So definitely, we need to promote the ethics and responsible use among our society. We have to bring back ethical issues into education, and that have, unfortunately, that have been laid behind in the last decades, right? And that's why this project, the Good project, concerning the one that we are doing, is actually super, super relevant. Thank you very much. I have another question from Dr. Cuevas, and she says, where do you see AI in 5 years? So I will dare to say that we're pretty close to achieve general intelligence. So, but we shouldn't be concerned about what it's going to be of AI in 5 years. Right now, we must start by focusing in today. What can we do today to actually prepare for what AI is doing today? If we match that point, then it will be a great opportunity, a great beginning for surpassing the challenges that overcome with AI. So I think our meeting has come to an end. Once again, I thank you very much for joining this talk, and please share with you what you have learned, get educated, and let's work together as a community towards facing these and other challenges that that are posed for humankind. Contact me. I will be glad to share new ideas with you. Thank you very much. Thank you. Thank you. Goodbye.